Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haitham Ali, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today you will have 25 questions on the Airbus A320 V2500 engine thrust reverser system. From this question, you will increase your performance and you will increase your understanding regarding the Airbus A320 V2500 engine thrust reverser system. I'm sure you know that the thrust reverser need to only deploy on ground. And we have at least 3 lines of defense to operate the thrust reverser on ground. What about the latch mechanism? What about the actuators? How the thrust reverser will be deployed? Hydraulically or pneumatically or what? And which computer control the thrust reverser operation? Okay, everybody, let's join the quiz now and have 25 questions on the thrust reverser system. So I will join the quiz right now. Haitham Ali. And let's start the quiz right now. Thrust reverser system for the V2500 engine. Okay, everybody. Question number 1. The thrust reverser system is hydraulically actuated utilizing the aircraft hydraulic pressure. Which system for engine 1? Which system for engine 1? Okay, just a moment. So, for thrust reverser operation for engine number 1, the right answer is the green hydraulic system. The green hydraulic system. I'm sure you remember that thrust reverser system for engine number 1 is powered by the green hydraulic system. Engine driven pump of engine number 1 for the green hydraulic system is used to power the thrust reverser system for engine number 1. What about engine number 2? For sure it is the yellow hydraulic system. Engine driven pump of that engine supply the thrust reverser system for engine number 2. So green system for engine number 1 and yellow system for engine number 2 for thrust reverser system operation. Thrust reverser system is hydraulically operated by hydraulic system and electrically controlled by the electronic engine controller for each engine. EEC is the main computer for operation of the thrust reverser system. It is used to energize the 2 solenoid valve inside the hydraulic control unit to select deploy sequence. Okay, everybody, let's proceed for the next question. Question number 2. How many translating sleeves for thrust reverser operation? They are 4, 2, 1 or 7. They are 2 translating sleeve per each engine. Each engine C duct is divided into left hand and right hand. So we have 2 translating sleeve, left hand translating sleeve and right hand translating sleeve for each engine. Yes. And we have each translating sleeve powered by 2 actuators, an upper actuator and a lower actuator, an upper actuator and a lower actuator. Okay, so we have 4 actuators per engine for thrust reverser system operation. These 4 actuators are synchronized to operate simultaneously with a synchronizing system utilizing a flexible shaft in the pressure port. Okay, everybody. So what about the upper actuator? They are called upper non-looking actuator or an LVDT actuator. And what about the lower actuator? They are called lower looking actuator and they are lock actuators. Okay, everybody. So as a summary, we have 2 translating sleeve per engine for thrust reverser system operation. When the translating sleeve are going aft, they exposing the blocker doors to bypass to the bypass airflow, and they are direct the bypass airflow or secondary airflow forward using the cascade vanes. Thanks to the cascade vanes, they are directing the air into the forward motion by certain angles to be away from flight controls or any other critical component of the aircraft. Okay, everybody, let's proceed for the next question, and I hope you enjoy my aviation nuggets. Always stay tuned for an upcoming sessions like this, and don't forget to subscribe to my aviation nuggets by Haytham Ali. Okay, let's proceed for the next question, question 3 of 25. The thrust reverser system is designed for use on the ground only to reduce aircraft landing rolling. This statement is very true. Yes, thrust reverser system operation is only on ground. Thanks to 3 line of defense, 3 computers or 3 systems managed by computers need to agree for thrust reverser system deploy. First line of defense, second line of defense, and third line of defense. First line of defense managed by the electronic engine controller of the engine. Second line of defense is managed by the engine interface unit concentrator. And the third defense independent line of defense is managed by an airframe system computer, which is the spoiler elevator computer, SEC, or spoiler elevator computer. Okay, everybody, thank you, and let's proceed. Question 4 of 25, next one. The hydraulic control unit is a third line of defense component in the thrust reverser system. This statement is false. Again, the hydraulic control unit is a third line of defense component in the thrust reverser system operation. No, the hydraulic control unit is a main component and not a third line of defense component. They are first and the second line of defense. They are having, or the hydraulic control unit is having, the isolation valve and directional control valve. For their energization and for the deploy of thrust reverse, EEC and EIU will deploy the thrust reverse. But as a third line of defense component, you remember it must be an airframe system computer. So the SEC is a third line of defense component in the thrust reverser system operation. The hydraulic shutoff valve is a third line of defense component for the operation of the thrust reverse. So in order to already have the hydraulic reach the hydraulic control unit, the shutoff valve must operate and must opening. It is the third line of defense component, and it will only open by a signal from the spoiler elevator computer at the selection or at the beginning of selection of the thrust reverse. The spoiler elevator computer must assure that the aircraft radio altitude is less than 10 feet before allowing the shutoff valve to open. So the SEC is a third defense line component. The shutoff valve is a third defense line of component. Yes, they are a third defense line, but they are the first action to happen. They are the first action to happen. Okay, everybody, let's proceed for the next question. Question 5 of 25. Main computer to control thrust reverser system. Main computer to control thrust reverser system. Is it the EIU or EEC or SEC? The right answer is electronic engine controller. Yes. The main computer for the FADIC is the main computer of thrust reverser system operation. The main computer for FADIC is the main computer for thrust reverser system operation. EEC will energize the isolation valve and directional control valve at the same time to deploy the thrust reverser, and the hydraulic will reach the 2 chambers in the actuator, the stow side and deploy side of the actuator, and due to differential area, the deploy side will win and the thrust reverser system will deploy. And the thrust reverser system will deploy. Okay, everybody? Let's proceed for the next question. Okay. Question 6 of 25. Third defense line component in the thrust reverser system. Third defense line component in the thrust reverser system. Is it the translating sleeve, hydraulic control unit, or hydraulic shutoff valve? The right answer is hydraulic shutoff valve. Yes, as the third defense line component is the hydraulic shutoff valve. This valve must be opened before hydraulic can reach the hydraulic control unit. So hydraulic will not reach the hydraulic control unit if the shutoff valve is not opening. So this is the third defense line component. Who open the shutoff valve? The spoiler elevator computer as an airframe system computer or an independent line of defense. The spoiler elevator computer will be commanded by a potentiometer inside the throttle control unit when the throttle lever at -3, less than -3 throttle lever angle. And the SEC will only close the power and static relay only if the aircraft altitude is less than 10 feet from the radio altimeter. SEC and the shutoff valve is the third defense line. They are third defense line, they are independent line of defense, but they are first action to happen. They are first action to happen. Okay, everybody. Let's proceed for the next question. Let's proceed for the next question. Question 7 of 25. Each translating sleeve is operated by two hydraulic actuators. The actuators receive fluid from the hydraulic control unit. Each translating sleeve is operated by two hydraulic actuators. The actuators receive fluid from the hydraulic control unit. This statement is very true. This statement is very true. Yes, each thrust reverser sea duct or translating sleeve is powered by a lower actuator, which is called a lower looking actuator, and an upper non-looking actuator, which is an LVDT actuator. The linear variable differential transducer will measure how many percent the actuator is opening, or how many percent the thrust reverser system is opening. And thanks to the LVDT, they will allow for safety feature happen in flight if in an advertent thrust reverser deploy happen in flight. You remember, for thrust reverser system, we have 3 auto as a safety feature. 3 auto as a safety feature. The engine will go to an auto idle. The engine will have auto restow for thrust reverser, and an auto thrust disconnection will happen if an inadvertent thrust reverser deploy happen in flight. Thanks to the LVDT will allow the AEC to know that an inadvertent thrust reverser happen in flight, and the EEC will manage auto idle and auto thrust disconnection and auto restow. What about the lower actuator? They are locking actuator, and the lock sensor and lock mechanism is part from the lower actuator. Okay, everybody, let's proceed for the next question. Thank you for your good listening, and always stay tuned for upcoming sessions like this. Okay, everybody, next one. When the deploy sequence is commanded, the pressure in the upper actuator release the locks. When the deploy sequence is commanded, the pressure in the upper actuator release the locks. This statement is false. This statement is false. Which part is false? Which part is not right? The pressure in the lower actuators, yes. Because the lower actuator, the locking mechanism, is part or an integral part from the lower actuator. An integral part from the lower actuator. The upper actuator is a non-locking actuators. And the upper actuator, they are called LVDT actuators. LVDT actuators. Okay, everybody. Let's proceed for the next question. Question 9 of 25. The directional valve operated to deploy only. The directional valve operated to deploy only. This statement is true. Yes. Only in case of deploy, only in case of thrust reverser system selection by pilots, the EEC will energize not only the isolation valve, but also the directional valve. The EEC has the responsibility to energize the directional valve, but this is not happening directly. The inhibition relay must be closed, and thanks to the engine interface unit and the second line of defense, the EIU will have the responsibility to energize the inhibition relay, so that the EEC can energize the directional valve. And keep in mind always that the directional valve operated to deploy only, energized to deploy only. If the EEC only energizes the isolation valve, we have stow operation, and the fail-safe design of this thrust reverser system is to stow. Always I need the thrust reverser system to stow. Okay, everybody. Let's proceed for the next question. Question 10 of 25. Which computer opens the shut-off valve so the hydraulic can reach the hydraulic control unit? Again, which computer opens the shut-off valve so the hydraulic can reach the hydraulic control unit? Is it the EIU? Is it the SEC? Or is it the EEC? The right answer is the spoiler elevator computer as an airframe system computer and a third line of defense computer. To deploy the thrust reverser, initially the spoiler elevator computer must open the shut-off valve. This will happen when a potentiometer in the throttle control unit reach less than -3 throttle lever angle. When the potentiometer in the throttle control unit sense a throttle lever angle less than -3, it will ask the spoiler elevator computer to open the shut-off valve. This will only happen when the spoiler elevator computer checks the aircraft altitude from the radio altimeter that it be less than 10 feet. Okay, everybody. I need to tell you that before commencing the next question, that the input for thrust reverser system come from the throttle control unit. And we have inside the throttle control unit, underneath the throttle lever, 3 components: a potentiometer, a resolver, and a switch. The potentiometer sends throttle lever angle to ask thrust reverser from the spoiler elevator computer. Dedicated switch for the EIU. And the resolver will ask the EEC. Okay, everybody. Let's proceed for the next question. Let's proceed. Question 11 of 25. Which computer energizes the inhibition relay? Which computer energizes the inhibition relay? Is it the engine interface unit? Is it the electronic engine controller? Or it's the spoiler elevator computer? To energize the inhibition relay, the EIU has this responsibility. The inhibition relay and the EIU is a second line of defense. And the EIU must energize the inhibition relay so that the EEC can energize the directional valve. The EEC can energize the directional valve only if the inhibition relay is energized and closed. And who energizes the inhibition relay or close the inhibition relay? It is the engine interface unit. Only when the dedicated switch inside the throttle control unit detects a throttle lever angle less than -3.8. It will ask thrust reversal system operation from the EIU. And only the EIU will close the inhibition relay when he is checked that the aircraft on ground from the landing gear control interface unit. From the landing gear control interface unit. Okay, everybody, let's proceed for the next question. Question 12 of 25. The actual state of the thrust reverser is shown on the upper E cam. Reverser indication appear in the middle of the N1 dial, E bar dial, or the EGT. Thrust reverser indication come on the V2500 engine on the E bar dial. The right answer is E bar or engine pressure ratio dial because it is the primary control engine parameter for that engine. Yes, in the V2500 the engine pressure ratio is the main control parameter or main primary parameter appear on the upper E cam engine and warning display. So a reverse indication come on the middle of E bar dial when thrust reverser system is in transit or thrust reverser system is fully deployed. If the thrust reverser translating sleeve in transit, a reverse amber indication will come in the middle of E bar dial. And only when the thrust reverser system is fully deployed, a reverse in green indication come in the middle of the E bar dial. E bar dial. Okay, let's proceed for the next question. Question 13 of 25. To help troubleshooting, a reverser test can be performed through the MCDU. To help troubleshooting, a reverser test can be performed through the MCDU. This statement is very true. And for maintenance purpose and for troubleshooting, maintenance personnel can perform thrust reverser system test on ground. Thanks to the centralized fault display interface unit. They will having the N2 signal as the engine is running to allow thrust reverser system test on ground with the engine not running. Okay. Also, you need to do this reverser test in case of aircraft dispatch with thrust reverser deactivation for flight. Okay. As a maintenance people, you need to do hydraulic deactivation, mechanical deactivation, having the lock pins in the lockout assembly. And the third procedure is to do a test on thrust reverser system after doing the deactivation procedure to check for the LVDT, linear variable differential transducer, because they are very important and you need to check that the LVDT is operable on the deactivated reverse, because the LVDT has the function for having the 3 auto in flight as a safety feature in case of inadvertent thrust reverser system deploy in flight. Okay, everybody, let's proceed for the next question. Question 14 of 25. Signal for reverser locked or unlocked come from the signal for reverser locked or unlocked come from the lock sensor on upper actuator, lock sensor on lower actuator, LVDT on upper actuator. The right answer is lock sensor on lower actuator. The lower actuator, they are called lower locking actuator, and they do have the latching locking mechanism. And the lock sensor has the responsibility to tell the AEC if thrust reverser system locked or unlocked. So at any time, if you have on ECAM reverse engine reverse unlock message on the ECAM, it is a no dispatch or a no go message for a normal flight or for a deactivated thrust reverser flight. Thanks to the lock sensor on the lower locking actuator. Thanks to the lock sensor on the lower locking actuator. Okay, everybody, let's proceed for the next question. Let's proceed for the next question. Okay. Question 15 of 25. The thrust reverser system is controlled independently for each engine by the associated FADEC system. The thrust reverser system is controlled independently for each engine by the associated FADEC system. This statement is very true. This statement is very true. Yes, the main system to control thrust reverser is the FADEC, and the EEC is the main computer for thrust reverser system operation to deploy or to stow. The EEC can energize the solenoid valve, directional and isolation valve inside the hydraulic control unit. Yes, the EEC need other assistant from the EIU and from the SIC, but the EEC is the main computer for thrust reverser system operation, and the FADEC system is the main system to operate thrust reverser system. Okay, FADEC is the EEC plus engine systems. So EEC and engine thrust reversal systems are part of the FADEC. Okay, everybody. Let's proceed for the next question. I hope you enjoy this set of questions. Question 16 of 25. A shut-off valve located upstream of the hydraulic control unit make up an independent looking mechanism or independent looking system. A shut-off valve located upstream of the hydraulic control unit make up an independent looking system. Yes, this statement is very true. The independent looking system, why it is called independent? Because it is a system not related to the engine, and it is managed by an airframe system computer, which is the SIC. Only inside the throttle control unit, when the potentiometer sense a throttle lever angle less than -3, it will ask the spoiler elevator computer to open the shut-off valve and allow the hydraulic to reach the hydraulic control unit. The shut-off valve will only open when the spoiler elevator computer assures that the aircraft altitude from the radio altimeter it is less than 10 feet. Less than 10 feet. Or the aircraft near to the ground. Okay, everybody, let's proceed for the next question. Let's proceed for the next question. Internal locks in the upper actuators, lower actuators, or both of answers, upper and lower. Internal lock in the lower actuators. Lower actuators. The lower actuators is a locking actuators, and the internal locks is an integral part from the lower actuator. They are released hydraulically. They are released hydraulically. Okay, everybody. Let's have the next question. Let's face the next question. Question 18 of 25. Synchronizing system in which hydraulic lines? The synchronizing system in which hydraulic lines? Deploy lines, stow lines, both of them. Deploy lines, stow lines, both of them. The right answer is deploy lines. The four actuators are synchronized by a synchronizing system, thanks to the flexible shaft, which is integrated in the deploy hydraulic lines. We must have a synchronizing system to allow thrust reverser deploy in the same degree and the four actuators to operate simultaneously at the same time with the same degrees or same percent. Okay, everybody. Let's proceed for the next question. Question 19 of 25. The hydraulic control unit include an isolation valve, a pressure switch, and a directional valve. The hydraulic control unit include an isolation valve, a pressure switch, and a directional valve. This statement is very true. Yes, the hydraulic control unit is the main hydraulic component for thrust reverser system operation. It do have an isolation valve and a directional valve. Only in case of deploy, both valve, isolation and directional will be energized. At any time, if the isolation valve only energized, it will command stow site or stow operation, not deploy. And we have a pressure switch after the isolation valve to check if the isolation valve is opened and to check the reverse pressurized. Okay, everybody. Let's proceed for the next question. Has a dedicated switch in the throttle control unit to ask for reverse. Has a dedicated switch in the throttle control unit to ask for reverse. It is the EIU. Is it the hydraulic control unit? Is it the electronic engine controller? Or is it the spoiler elevator computer? The right answer is the engine interface unit that do have a dedicated switch inside the throttle control unit. And this switch, when it is sensed throttle lever angle less than minus 3.8, will ask the EIU to energize the inhibition relay. And the EIU will only energize the inhibition relay when the aircraft on-ground signal comes from the LGCIU. When the inhibition relay is closed, now and only now, the EEC can energize the directional valve. Okay, so the EIU, the engine interface unit concentrator, is a computer that do have a dedicated switch inside the throttle control unit to operate thrust reverse or to ask for thrust reverse. Okay, everybody. Let's proceed for the next question. I hope you enjoy this set of questions. Next one. At which throttle lever angle the inhibition relay will be energized by the EIU? At which throttle lever angle the inhibition relay will be energized by the engine interface unit? Is it less than minus 3 degree? Is it less than minus 3.8 degree? Is it less than minus 4.2 degree? The right answer is less than minus 3.8 degree. The potentiometer will ask for reverse operation to the SEC when the throttle lever angle is less than minus 3. And the switch will ask the engine interface unit to thrust reverse when the throttle lever angle sensed by the switch less than minus 3.8. And only when the throttle lever angle is less than minus 4.2, the resolver in the throttle control unit will ask for thrust reversal system deploy from the EEC. So we have three angles at minus 3, minus 3.8, and minus 4.2. Minus 3 is the SEC. Minus 3.8 is the EIU. And minus 4.2 is the EEC. Okay, let's proceed for the next question. Everybody, I hope you enjoy this set of questions. Question 22 of 25. The EEC can energize the isolation valve solenoid only. The EEC can energize the isolation valve solenoid only. This statement is false. The EEC can energize the solenoid of the isolation valve and the directional valve. Isolation valve and the directional valve. Yes, the EEC can energize the isolation valve directly, but the EEC, in order to energize the solenoid of the directional valve, this action must be done through the inhibition relay. And the inhibition relay must be energized or closed to allow the EEC to energize the directional valve also. So both solenoid valves, directional and isolation inside the HCU, can be energized by the EEC. Okay, everybody, let's proceed for the next question. Question 23 of 25 are used to monitor the thrust reversal position and for EEC control. Is it the lock sensor only? Is it the LVDT only? Or both of them? The right answer is both of them. Lock sensor indicate on the EBAR dial status of thrust reversal system. Reverse in amber in transit. Reverse in green will come when the thrust reversal is fully deployed. And the LVDT monitors the percent of deployment. And they are very important because they will have a big role in an auto restow or auto redeploy operation if any error happen in flight. Okay, and the LVDT will be needed by the EEC to have the safety feature on thrust reverser system in flight. Auto idle and auto restow and auto thrust disconnection will depend on the LVDT measurement of thrust reverser system operation in flight. Okay, everybody, let's proceed for the next question. Question 24 of 25. Tying locks within the lower actuators are hydraulically released before translating sleeve movement occur. Again, tying locks within the lower actuators are hydraulically released before translating sleeve movement occur. Yes, the lower actuator have the lock mechanism. The lower actuator have the lock mechanism. And the lower locking actuator must be released at first by hydraulic in order to have deploy operation. Okay, let's proceed for the next question. Question 25 of 25. The LVDT actuators is the upper actuators. The LVDT actuators is the upper actuators. This statement is very true. Yes, the upper actuator is the non-locking LVDT actuator. And the lower actuator is the locking actuators. Okay, everybody. Thank you, everybody, for your good listening. Thanks a lot. And always fly safely and maintain your aircraft very safely. Please stay tuned for an upcoming sessions like this. Hosted by Haysam Ali. Thank you. I hope this set of questions allow you to recall the thrust reverser system operation for the V2500 engine. Thank you. I will meet you again very soon, and goodbye.